Keeping Montserrat alive.
This is 95.5,
88.3 FM,
ZJB Radio.
Keeping Montserrat alive.
This is 95.5,
88.3 FM,
ZJB Radio. ZJB Radio.
Good morning, Montserrat. My name is Vita Wade, and welcome to MVO Talks. I am the acting education and outreach officer. Good morning, Montserrat. My name is Vita Wade, and welcome to MVO Talks. I am the acting education and outreach officer. Okay, I think we need to take that again. So my name is Vita Wade, and I'm the Acting Education and Outreach Officer at the MVO. And so welcome to MVO Talks. This week, starting today, we're observing 25 years of volcanic activity on Montserrat through some very lively and engaging discussions with the staff of the MVO, as well as regional and international experts, as we discuss the history, the lessons learned, and the future challenges of our volcano, our Soufriere Hills volcano. So just to start with a little bit of housekeeping, if you are experiencing any technical difficulties on Facebook or at all via your mobile, etc., just try closing the page and coming back on afresh. We're encouraging our radio listeners and our Facebook followers to log on and participate in these discussions. At the end of our presentation, there will be a question and answer section for you to feel comfortable to call in and ask those questions. You can do so via WhatsApp on telephone number 1664-495-2029, or you can call in to Radio Montserrat on 491-7227. We are live on Facebook, GIU Montserrat, as well as MVO's Facebook page. So to start today's discussion, we will begin our week of activities at the MVO Talks with a special message from the MVO Director, Dr. Graham Ryan, who will share a pre-recorded message from Trinidad.
On behalf of the staff of the Montserrat Volcano Observatory, served by many people to serve the people of Montserrat to the best of its ability. This week, we at the MVO will be sharing some insights about our volcano. This eruption has had a profound effect on the people of Montserrat. Lives have been lost, homes have been destroyed, livelihoods have been taken, and people have been forced to leave their home country. This eruption has created enormous challenges for the people of Montserrat, but sometimes opportunities arise from the gravest of circumstances, and Montserrat remains a wonderful home. This week, the staff of the MVO will be speaking about our island and volcano. The topics include how Montserrat came to exist, how this eruption started and how it has unfolded, and the warning signs that preceded it. There will be the launch of the wonderful Mountain Aglow website. This site shares, among other things, the personal experiences of the people of Montserrat through our stories, music, and poetry. This website will be an excellent tool for passing on this important history to the younger generation. There will be a discussion about how we monitor the volcano and the challenges presented by having to work on an active volcano. There will also be a fascinating discussion with former Premier Ruben Mead, Major Alvin Ryan of the DMCA, and both regional and international volcanologists. They will be talking about the lessons we have learned from this eruption, as well as the remaining challenges. On Saturday, there will be a special edition of Volcano Vibes on ZJB, where the panelists will discuss some of the opportunities created by this eruption. In summary, the MVO welcomes you to join us over this week and have a conversation about our volcano and how our lives have been shaped by it. We look forward to seeing you all virtually.
Thank you. Thank you so much to Dr. Graham Ryan. So we're going to kick off today's MVO Talks with a presentation by Dr. Adam Stinton. Dr. Stinton's presentation will be on the geological history of our island. And so just to share a little bit about Dr. Stinton with you, his main responsibilities at the MVO include dome and deposit surveying, deposit mapping, and sampling. As with all MVO scientific staff, Adam's work also involves research in a number of areas, such as behavior and hazards of pyroclastic density currents and explosive activity. Also, morphological evolution of active lava domes, application of ground-based aerial and satellite imagery for monitoring volcanic activity, and volcanic history of Montserrat and the evolution of the Northeast Lesser Antilles. We look forward to Adam's presentation, and without further ado, over to Adam.
Thank you, Vita, for that introduction. As Vita says, my name's Dr. Adam Stinton. I'm one of the volcanologists on staff at the observatory, and I've been working here on Montserrat for nearly 11 years now. So as the first talk in the series this week, I'm going to be just sort of laying the ground truth or the background to Montserrat, covering a little bit about its geologic history, about how the island came to be, and how it's talk about the different volcanic centers that are present on the island. And then at the end of the talk, I will sort of summarize some of the key points that I have mentioned. So first off, for those of you that may not be familiar with Montserrat, we are located here in the Eastern Caribbean, about 50 kilometers southwest of Antigua and about 80 kilometers northwest of the French island of Guadeloupe. Montserrat is part of the Lesser Antilles island arc. It's a chain of islands that includes Guadeloupe, Martinique, Dominica, St. Lucia, St. Vincent and the Grenadines, and others, all of which have a volcanic origin. And this chain of islands, as I said, known as the Lesser Antilles Island Arc, is a result of subduction of Atlantic Ocean crust in the form of the North American and the South American tectonic plates. They're subducting beneath the Caribbean plate. So the Atlantic Ocean crust is moving very slowly at about 2 centimeters per year towards the west, while the Caribbean plate in relative motion is moving towards the northeast at about northeast at about 2 centimeters per year as well. And this process drives the Atlantic crust beneath the Caribbean plate, and as that descends deep into the Earth's mantle, the Atlantic plate melts, and these buoyant masses of recently melted plate rise to the surface and form the volcanoes that you see on each of the islands. Looking at the island arc in a little bit more detail, the island arc has been around since about the early Eocene, or I should say it's a Cenozoic age island arc, and it has had volcanism in two distinct periods. The first of which lasted from the early Eocene to the late Oligocene, and then a pause of around 10 to 15 million years, with a second phase of volcanism, which began in the mid-Miocene, or about 11 to 12 million years ago, and continues until present day. The island arc is actually split into two. From, as you can see, for those following on Facebook, you can see the graphic on the right-hand side of the screen, and you can see that from Guadeloupe northwards, the island arc chain is split into two branches. The islands in the eastern branch are known as the limestone Caribs. They are mostly islands that are made up of mostly limestone deposits, although some of them do have some older volcanics mixed in with them, such as Antigua. Whereas the islands to the west, in the western branch, and in islands south from Guadeloupe southwards, they are known as the volcanic Caribs, and they have all the present or recently active or potentially active volcanoes in the island. And as you can, for those of you following on Facebook and on YouTube, you can see each island has at least one potentially active or active volcano, apart from Dominica, which has quite a number of potentially active volcanic centers. Throughout the lifetime of the Lesser Antilles Island arc, there's been a couple of some notable eruptions that have occurred in recent times. One of these is the 1902 eruption of Mount Pelée in Martinique, which caused around 29,000 fatalities. And of course, the other notable eruption is the one here on Montserrat of the Soufriere Hills volcano, which began in 1995, and while still essentially ongoing, there's been no lava extrusion since about 2010. The island chain also has, in the southern part, just north of Grenada, a submarine volcano, and this is actually called Kikimjeni, and this is actually the most active, or certainly one of the most active volcanic centers in the island arc. As the island arc is formed by the interaction of two tectonic plates, earthquakes are obviously also a major feature too, and there have been numerous large earthquakes throughout the centuries, but two notable ones are a magnitude 7.4 that occurred in 1975 to the northwest of Antigua, and then in 2004 there was a magnitude 6.3 near to Dominica. So if we zoom in on the northern part of the Lesser Antilles arc, where we have these two branches, and you can see, for those of you following online, you can see a map here showing the two chains with all the islands labeled. When we start looking at the ages of these islands, we can see a distinct difference in age between those located in the eastern branch compared to those located in the western branch. For example, the islands of San Martin or Saint Martin, Saint Bart's and Antigua, they have volcanism, or they have had volcanism present on the islands, but the volcanism there ended or occurred between sort of 24 and 38 million years ago. If we jump to the western branch in the northern part of the island arc, islands like Sabre, Statia, St. Kitts, Nevis, and of course Montserrat, the volcanism here is much younger, no more than around 2.5 to 3 million years old. So there's a significant gap in time between the volcanism in Antigua and St. Barth, St. Martin, and that here in Montserrat and St. Kitts, Nevis, and the other islands. And this is a result of, essentially there was a pause that lasted for well over 10 million years, in the volcanism caused by the interaction of what's called an aseismic ridge on the Atlantic crust as it entered into the subduction zone. So essentially, this aseismic ridge is a sort of topographic rise on the subducting Atlantic plate that essentially jammed up the subduction process, causing volcanism at the surface to stop as there was a readjustment in the subduction process in the subduction area. And this readjustment basically caused islands like Antigua, Barbuda, St. Barts and St. Martin and the eastern half of Guadeloupe to become tilted upwards. That tilt and uplift resulted in this 50 kilometers or so westward shift in the focus of volcanism. But it took around 10 to 15 million years for this shift to occur and for the volcanism to start, or at least reach the surface anyway. If we look a bit more closely at the area surrounding Montserrat, there's been a lot of seafloor mapping occurred using various ships over the last 20 years or so, because of the focus of the volcanism has generated a lot of scientific interest on Montserrat, on the activity, and also the surrounding seafloor. And mapping of the seafloor has produced some detailed information on the structure of the seafloor, and has also led to the discovery or the detailed study of some important geological features on the seafloor. The primary features that have been studied are a series of faults that run sort of northwest to southeast across the seafloor and through Montserrat. These faults have occurred as a result of the oblique convergence between the Caribbean and the Atlantic crust. If you remember earlier, I mentioned that the Caribbean plate is moving in a relative motion towards the northeast, whilst the Atlantic crust or the Atlantic plates are moving more towards the west. And this oblique convergence, this oblique meeting between the two plates, has caused a series of faults to form to accommodate the forces and the lateral movement that has occurred in this area. For those of you watching online, you can see the map on your screen. We've obviously got Montserrat in the center, and you can see a series of faults that sort of line up in like a stepwise fashion. So if you were to walk from the bottom right to the top left of the image, you're essentially moving up a series of steps. And that describes how these faults are aligned. If we look a bit more closely in Montserrat, you can see that where this fault system crosses the island, it essentially controls the location of the present volcano, so the Soufriere Hills volcano and the lava domes surrounding the present lava dome, and also the location of places like St. George's Hill and Garibaldi Hill. And on land, this fault system is known as the Belem Valley Graben, and has led to subsidence in over periods of hundreds of thousands of years of very small amounts. We're talking centimeters or millimeters per 1,000 years or so, and also some different. Some of the areas like St. George's Hill and Garibaldi Hill have been uplifted or pushed up, even though we've got this zone of general subsidence. Right, so that hopefully provides you with a little bit of background on how Montserrat came to be, and sort of the geologic setting for the island. As I'm sure a lot of people know, I'm sure everybody living on island knows, we have at least one volcano on island. where actual fact, the island consists of 4 different volcanoes. In the very north of the island, we have the Soufriere Hills volcano. This is the oldest part of the island, and this volcano was active from around 2 to about 1 million years ago. Moving further south, we have the Center Hills, which are located roughly in the center of the island. They're one of the largest volcanic centers on the island. And this group of this volcanic center was active between about 1.1 million and 0.4 million years ago. And then moving further south again, we have the current volcano, the Soufriere Hills volcano. This has been active since for the last 450,000 years or so. And then in the very southern part of the island, we have the youngest volcanic center, the South Soufriere Hills, which was essentially just a one-off eruption, very short period of activity, which occurred between about 130 and 120,000 years ago. So the South Soufriere Hills was active for only around 10,000 years, which in terms of the lifetime of a volcano is quite short, but in terms of human lifetime is quite a long time. So now as you may have seen, or for those watching online, you will have seen that some of the ages of the volcanic centers overlap, and a lot of research has gone on island to studying not only the current volcano but also the older volcanoes to learn more about the formation of the island, and just to see how we can apply the knowledge that we learn from Montserrat to some of the other islands within the Lesser Antilles and also within similar sort of tectonic or volcanic settings around the world. And when you start looking at the ages of the island, of the different volcanic centers, it's clear that there's overlap between each successive pair of volcanic centers. So the Soufriere Hills overlaps, or activity within the Soufriere Hills overlaps a little bit with activity from Center Hills. And likewise, there's an overlap between the Center Hills and the Soufriere Hills. For those of you that are watching online, you can see this graphic that clearly shows that. And we can see there's an overlap of a few tens of thousands of years between both the Soufriere Hills and the Center Hills and the Center Hills and Soufriere Hills. Obviously, with the South Soufriere Hills being a unique sort of almost one-off eruptive event, that has occurred during the same time that the Soufriere Hills has been active. And when you start doing this detailed dating of the rocks and eruptive periods on Montserrat, and also within other islands in the Caribbean, you start to realize that actually this is a common occurrence on islands in island arcs like the Lesser Antilles. So these features, this sort of overlap between activity, it seems to be a common feature. And it's important to note, however, though, these dates are just for activity that has occurred since the island has breached the surface of the sea. Although the oldest date we have the island is around 2.5 to 2.8 million years old, that only corresponds to activity at the surface, i.e. above sea level. Obviously, in order to get the volcano up above sea level, you had to start building it from the sea floor, and that probably occurred, it could have occurred, several 100,000, maybe 1 million or more years before the activity reached the sea. And we have evidence for this. As I mentioned earlier, there's been a lot of work done on mapping the sea floor. And to the east of Montserrat lies a group of volcanic centers which are currently at least 600 meters below sea level, below the sea surface. and those volcanoes were active around 5 million years ago. So we know that between the ending of volcanism in places like Antigua and the start of subaerial activity, i.e. that above the sea surface, volcanism was occurring in the gap between Antigua and Montserrat. So we know that there was a westward migration. Another aspect of the detailed mapping and studies into the rocks and the volcanic centers here on Montserrat is that although the general chemistry of the eruptive products, i.e. the lava domes, the pyroclastic flow deposits, and what have you, although they're generally speaking fairly consistent throughout the lifetime of the island so far, if you really start digging deep into the chemistry of the rocks and looking at specific isotopes, in this case the isotope called lead, you can start to see patterns and trends that allow you to differentiate between the different volcanic centers on island. And this is key when you're mapping the deposits from the periods that correspond to when we had activity in two volcanic centers at one time. So when you have the overlapping activity, if you look at the lead isotope data, it can tell you which center that particular block of lava or what have you came from. So this is another interesting part of the work that's gone on here on Montserrat that has allowed you to essentially fingerprint the different types of rocks or the different lava products based on the lead isotopes and being able to assign them to the different centers. All right, now we're going to move on through each of the different volcanic centers on island, going into each one in a little bit more detail. Starting with the oldest volcanic center on the island, the Soufriere Hills. For those of you on island, this is the small group of hills located at the very northern part of Montserrat. Its present elevation is just 392 meters above sea level. And as I said, as I've already mentioned, it was active between sort of approximately 2.1 and about 1 million years ago. So this volcanic center was fairly well long-lived, being active for just over 1 million years of activity above sea level. And the Soufriere Hills, as with all the volcanic centers on island, consists of a series of dome building or lava domes that have been formed during various series of dome building eruptions, and at times these have collapsed. These domes have collapsed in a very similar way to the collapses that have occurred in the Soufriere Hills during the last 25 years or so. There have been intermingled with these dome building and dome collapse eruptions, there's also been some minor amounts of explosive activity, so big explosions that generate ash plumes and fallout covering a wide area. But obviously at the time of this, when the Soufriere Hills was active, the Soufriere Hills was the only part of Montserrat that was above sea level. So most of the deposits from these activity are actually on the sea floor. On the right-hand side, for those watching online, you have a series of maps of the Soufriere Hills showing the progression of the activity during the lifetime of the Soufriere Hills. And you can see it's sort of moved, the focus of the activity, or the center of the activity within the Soufriere Hills, moved around, starting in the southwest and then the southeast, and then moving to the northeast. And so on, with different different dome building eruptions, some volcanic explosions. There was obviously some collapses, particularly sort of around 1 million years ago, or 1.5 million years ago. There was some large collapses to the north, and also mixed in with this, once one of the volcanic centers sort of died off, or one of the lava domes had finished forming, you started to get a lot of alteration of the lava domes and the surrounding blankets of pyroclastic flow material. So you would have had pyroclastic flows associated with these eruptions, and the once the formation of the lava domes and the eruptions had ceased, and sometimes during the formation of these eruptions, you have alteration of the deposits, so forming these bright yellow, reds and orange coloured sort of fumarole deposits, or soufrières as we call them on Montserrat and in the Eastern Caribbean. And there are some very extensively altered areas of the Soufriere Hills, and but none of these are now active. The Soufriere Hills is definitely an extinct volcanic centre. Moving on to the centre hills, as I said, this is one of the largest volcanic centres on the island. It reaches a height of 740 metres above sea level. And this, as I've already mentioned, was active between sort of 1.1 and 0.4 million years ago. So it was active for around 700 to 800,000 years. Again, a fairly long-lived volcanic centre. And again, just with the Soufriere Hills, and it consists of a series of large lava domes that have built up over the course of many hundreds, if not thousands of years. But one of the key features of the centre hills is actually the explosive activity that occurred during the lifetime of the centre. The centre hills is actually one of the most explosive, if not probably the most explosive volcanic centre on island, generating extensive pumice-rich deposits, exposures of which are best seen in the coastal cliffs on the west and east coasts. For those of you online, this is an aerial photograph looking north of Montserrat, just showing you the rugged feature, the rugged centre hills here in the middle, which are also heavily forested, making mapping work almost impossible in pretty much most of the centre hills. And here on the north, here are the Soufriere Hills to the northeast. So you can see the relative sizes, the relative size of the centre hills versus the Soufriere Hills, giving you an indication that the centre hills are in fact younger than the Soufriere Hills, which is one way that the early geologists working on Montserrat distinguished between the different volcanoes, was based on their size and their shape. But as I've just mentioned, the centre hills is one of the most explosive volcanic centres on the island, and mapping work looking at the different coastal outcrops and some of the exposures of the deposits inland has shown that there are at least 12 episodes of extremely explosive activity. For those of you watching online, you can see this graphic shows you a series of what we call stratigraphic logs, where you go to an outcrop and you describe the different layers of rocks that you can see, and each of those colors represents a different phase of this explosive activity. So you can see in the cliffs in the western along the west coast in particular, the outcrops or the evidence for this highly explosive activity is very prominent. I'm currently showing a photograph of the sea cliffs just to the north of Buncombe Bay, and in it there's two prominent pale-coloured units that are over 10 meters thick, and these pale-coloured units are a mix of pumice fall, so blocks of pumice that would have been thrown up into the atmosphere during one of these explosions and then rained back down to earth, to the ground, and also these pumice-rich pyroclastic flows that are just mantling and covering the topography that existed at the time. Again, during the formation of the Center Hills, the topography was very different compared to what it is now. Obviously, you had the Silver Hills volcano, but you still had nothing south of the Center Hills. This next photograph that I'm showing shows a different series of layers, again from the Center Hills, but highlighted is a 2-meter thick pumice fall unit located in the shallow cliffs, or in the low cliffs at Bransby Point. Now these cliffs are about 5 to 6 kilometers from the Center Hills. So we've got more than 2 meters of pumice fall, over 5 to 6 kilometers away from the Center Hills volcanoes, just reinforcing how big and how explosive these eruptions were. And some of these pieces of pumice that you can see in this outcrop are fist sized, so they're not small. Now we're going to jump forward to the Soufriere Hills, which is the currently active volcano. This volcano, the volcano at present, reaches 1,080 meters above sea level. So the summit of the present volcano is the highest point on the island, and the center of the volcanic center, that is the Soufriere Hills, has been active for over 400,000 years so far. And during that period, activity has led to the formation of places like Chance's Peak, Gage's Mountain, Galway's Mountain, and Perch's Mountain. And those are all volcanic lava domes that formed prior to the present one. For those of you that know Montserrat quite well, you will know the English's crater, which existed prior to the present eruption. And within this was the volcanic dome of Castle Peak, which was destroyed at the start of the present eruption. And again, the activity in Soufriere Hills, as those of you who have experienced it will fully understand and know, that it involves the formation of lava domes with extensive pyroclastic flow activity. We've had numerous explosions during the years. I think it's something like over 100 explosions during the activity. And also there have been large collapses of the lava dome. This map, for those of you watching online, just shows you the distribution of the older volcanic domes surrounding English's crater and Castle Peak, which essentially marks the location of the present lava dome. And here are a few photographs just showing you the sorts of activity which I'm sure everybody who's been on Montserrat at any point during the last 25 years will be familiar with. We've got pyroclastic flows, the lava dome, and so on. This map shows the deposits from the last lava dome collapse, and Dr. Christopher will go into more detail about the sorts of events that have occurred during the last 25 years. One feature of southern Montserrat and the activity in the last from the Soufriere Hills is that it's generated activity on the ocean floor in terms of pyroclastic flows, and collapses have entered the sea and traveled across the sea floor, sometimes reaching almost all the way to Guadeloupe. Right, our final center on Montserrat is the South Soufriere Hills. And this is the shortest lived and the youngest. And as I said before, it's essentially a one-off eruption, lasted around 10,000 years. What's unique about this center, not just its period of time, but also the fact that it contains slightly different products. During the formation of the South Soufriere Hills, we've had proper lava flows formed, or erupted, and we've got thick beds of scoria. I have here a photograph, for those online, of a sequence of the scoria beds. You can see all those black deposits behind Dr. Christopher there for scale. showing you just how thick and extensive these scoria beds are. And this activity essentially occurred within 10,000 years. Right, to summarize, Montserrat is part of the Lesser Antilles island arc, which is a Cenozoic arc in age, beginning with activity in around the early Eocene. There was a 10 million year gap roughly in the northern part due to the interaction of this aseismic ridge with the subduction zone. The oldest volcanism on the island dates back more than 2.1 million years or so, but obviously volcanism occurred on the seafloor before this. And during the growth and development of Montserrat, there's been overlap between the different volcanic centers on island. And we've got the 4 volcanic centers. We've got the Soufriere Hills in the north, which was active for around 1 million years. The Center Hills, which was active for around 750,000 years. Again, both characterized by lava domes and pyroclastic flows. The Center Hills obviously having the most explosive activity. We've got the present Soufriere Hills, which was active, or is currently active and has been so for around 450,000 years. And then, of course, we've got the South Soufriere Hills volcano, the very southern part of Montserrat. So, thank you. That concludes my talk for today.
Thank you so much, Dr. Stinton. That was so informative. I've personally learned so many things I didn't know about. Perches Mountain, Castles Peak are totally new to me, and I really appreciated your, context of the sea cliffs around the island as well. Now, we're open for question and answer, and so let's talk. We're looking forward to your questions. I know we've had some online followers on Facebook, and so Dr. Adam, one of the questions that came in is what technique is used to determine the age of the rocks?
So the technique that we use for this is called argon dating, and this is where we take a very small sample of the rock, and then essentially we measure the amount of argon gas that's present within the rock. But in order to do this, though, you have to essentially crush the sample up, heat it up, and put it next to a small nuclear reactor for a period of time. So there's only a few places in the world that can obviously do this sort of technique, and basically you measure the amount of argon gas that's given off when you heat up the sample after it's been irradiated, you put next to the nuclear source, and then based on that based on the amount of gas that you measure, argon gas you measure coming off, and comparing that to the amount of argon gas present in the atmosphere and throughout time, you can work out an age, and it's pretty accurate. It's accurate to within. It can be accurate to within a couple of thousand years. So we can get some really, really accurate dates, which is how we're able to really believe that we have these overlapping periods in activity on Montserrat.
Absolutely amazing. Right. Now, for the next question, what is the chemical composition of the erupted materials by the different volcanic centers? Andesitic or rhyolithic?
Right. So the bulk of the material that's been erupted by the volcanoes here on Montserrat is called andesite. But as I mentioned, the South Soufriere Hills is slightly different. It's much more basaltic in composition, which means basaltic rocks are very similar to the sorts of rocks you might find erupting in Hawaii, although the ones that are erupted here are not quite as fluid as those that you find on Hawaii. So the basaltic rocks have a lot of silica content in them, or silica dioxide, that sort of element, which enables the magma that reaches the surface to flow easier compared to with the andesite products that erupted from the other volcanoes on Montserrat, which have a higher content of silica, so that makes them more sticky, more viscous, and therefore they don't flow so far. The magma doesn't flow as much when it reaches the surface, and hence why it produces these lava domes and these more explosive eruptions.
Okay, thank you for that. I hope our follower on Facebook is still there and is able to benefit from that answer. Now, I've got two questions for you that I really want to try and squeeze in before we're finished. And the first one is, I've actually got more than two, but the first one is, how do you know if Silver Hills or Center Hills is not going to erupt anymore? You know, at which point does a volcano become extinct?
Well, as we've shown, the ages of these volcanic centers are they are the oldest parts of Montserrat. So the Silver Hills is over 2 million years old. Center Hills is about 1 million to 500,000 years old, and the fact that the volcanism in Montserrat has migrated southwards with time clearly indicates that each volcanic center has its own source for the magma that rises. So the sources of magma for the Silver Hills and the Center Hills are no longer viable. They're not going to produce any more magma or melt to reach the surface. And we know this partly because of all the earthquakes that occur on Montserrat associated with volcanic activity are solely concentrated around the present volcano. So if we started to see earthquakes further north happening, then, well, if earthquakes were occurring further north, then perhaps they would be associated with something going on in those areas. But all the volcanic activity is currently concentrated in Soufriere Hills because of all the earthquakes that are occurring. That's how we can tell.
Interesting. Okay, so we've got an old volcanic structure or area in Silver Hills.
Mm-hmm.
Activity died. Then we've got activity in Center Hills, and the activity then went south to Soufriere Hills and South Soufriere Hills. And to be honest, I actually just thought we had Soufriere Hills and that was it. But we have Soufriere Hills and South Soufriere Hills. Now, does this mean that there is a sort of trend to, what's going to happen next? Are we potentially going to get a volcano south of South Soufriere Hills? And is that the direction the island is growing?
Yes, that's, as I've mentioned earlier, the volcanism has migrated southwards in the formation of Montserrat, and we see this sort of pattern elsewhere in the Caribbean. Particularly, one of the best examples of this is on the western half of Guadeloupe, where volcanism has also migrated southwards. So the present volcano, the present potentially active volcano, is at the very southern end of Guadeloupe, or of Basse-Terre, I think is the island it's on. And yes, potentially in many tens of thousands, if not hundreds of thousands of years, there could well be another volcano occurring to the south of South Soufriere Hills. So we're going to have to come up with some sort of new name for that if people are still around at that time. So yeah, essentially the volcanism could well migrate further southwards.
Okay, we're running out of time, but we have got a couple more questions here on Facebook that I'm going to share with you. Danny Joseph asks, can you give examples of how the improvements in technology over the past 25 years have improved or helped your work?
That's a great question. Yeah, there's been, the amount of focus and attention that's been paid on Montserrat during the last 25 years has led to some significant advances in technology and in the science and in the understanding of the activity. One of the instruments I used as part of my monitoring work on the island is a radar instrument, and essentially this is ground-based, so it sits on top of a hilltop, pointed at the lava dome, and it basically scans the lava dome, generating a 3D topographic surface. And this radar instrument, so it uses technology like planes and airports do for detecting, for locating the presence of airplanes and what have you. This technology actually allows us to be able to sort of see through any clouds that are on the lava dome. Being a tropical environment, we have clouds covering the volcano pretty much every day, and it makes it difficult to monitor at times. So this radar allows us to see through these clouds and be able to gather data on changes on the lava dome 24 hours a day, 7 days a week, 365 days a year. So basically, and we can get data in almost near real time as a result of this on changes in the lava dome. So that sort of technology has come on within the last 20 years or so, and is a really critical and fantastic tool that we have here on Montserrat.
Thank you so much. Yes, it's certainly much easier than it would have been in those, hundreds of years ago. I can't imagine how scientists would have even attempted to monitor volcanoes then. But thank you so much, Dr. Stinton, for your very informative presentation. Thank you so much to our followers on Facebook, and for your questions as well. We look forward to being back with you again tomorrow. We're going to have Dr. Thomas T.C. Christopher, and he's going to be discussing the overview of the ongoing Soufriere Hills eruptions. And to just end, I'd like to say thank you so much to Radio ZJB for having us, to GIU for helping to facilitate the technical aspects of this presentation, and again to you, Dr. Stinton, thank you so much for taking your time out of your busy schedule. I know you're also acting director this week, and so your hands are full, and so thank you so much.
Yep, you're welcome.
Thank you. And so just to finish everything off for the day, I just want to remind everybody that we are still having our 25th anniversary conference. Is going to be postponed to 2021, which is next year. But for more this engaging discussions, please continue to be locked into MVO Talks. On Friday, we're going to have a big reveal as to when the new dates will be for SHV 25. Thank you again, and if you have any questions, please continue to post them on Facebook, and our team will be very happy to answer them. Until next time tomorrow, goodbye.
Keeping Montserrat alive.
This is 95.5
88.3 FM.
ZJB Radio.
Keeping Montserrat alive.
This is 95.5
88.3 FM.
ZJB Radio.